This is the recording for online lesson 3. Again, for this section, we'll be looking at triangles on a coordinate plane. Please remember all triangles need to initiate at the origin with angle theta as the interior angle, and your right angle always being perpendicular to the x-axis. Your x and y values represent the horizontal and vertical distance, and we can call the hypotenuse the radius. For now, the radius is always going to be positive because diagonals always will be positive. When we think about our trig ratios, I'm just going to deal with the basic right triangle trig, although we can take its reciprocal at any point. Sine of theta is going to be opposite over hypotenuse. Cosine of theta is going to be adjacent over hypotenuse. And tangent of theta is opposite over adjacent. So when we're looking at those three ratios or their reciprocal ratios, because all of our values in quadrant 1 have a positive x and a positive y, all 6 trig ratios will be positive in quadrant 1. When we move into quadrant 2, because we have a negative x, all of our ratios that use x will also be negative, meaning that only sine and its reciprocal are positive in quadrant 2. As we move on to quadrant 3, both values are negative. So the only one that's going to be positive is going to be your tangent, because that's going to be a negative divided by a negative. So we need to be aware that tangent and its reciprocal function are positive in quadrant 3. Once we move on to quadrant 4, we notice that it's the y value that is negative. So our ratios that involve y are going to be negative, leaving cosine to be positive. The way we can remember this is by using a little acronym. I remember all students take calculus, and that allows me to see that which ones will be positive in each quadrant. What I want you guys to do is try this one on your own, again thinking about where it will be positive and where it will be negative. In this situation, we have the point -2, 7. I'll start by helping you guys draw the picture. Again, we're starting at the origin. We're going to go 2 units backwards, 7 units up, and draw our triangle. The right angle is always going to be perpendicular to the x-axis, with angle theta being the interior angle. From here, you guys would need to find your hypotenuse using Pythagorean theorem, and then calculate your 6 trig ratios. The answers for this will be given in our Zoom meeting. For this one, your information is going to be slightly different, but yet similar. This one's going to start by giving you 1 trig ratio and also let you know that cosine is going to be positive. So if we think back to that acronym, all students take calculus, we need a quadrant in which tangent is negative and cosine is positive. That would be in quadrant 4. So that tells us where the triangle is going to initiate. So I'm going to draw my triangle into quadrant 4. Again, that interior angle is always going to be theta, initiating at the origin, right angle perpendicular to the x-axis. Our tangent ratio is opposite over adjacent, so that helps us see that that ratio is -12/5. From there, we can use Pythagorean theorem means that the hypotenuse is 13. Once we get that, we have all three sides, then we can set up our 6 trig ratios. Sine of your angle is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Again, this was one of the ones that was provided for us. Once you have your 3 trig ratios, then you find your other 3 reciprocal ratios. Cosecant is negative 13 over 12. Again, it's not saying that the hypotenuse is negative, but we're moving the negative in front because that's where negatives belong. The reciprocal of cosine is secant. If cosine is positive, its reciprocal is positive, and we just flip it. The reciprocal of tangent is cotangent. And again, we flip, making sure that the negative is in front of our function. The next thing I would like to discuss is remembering that we can convert units from radians to degrees. Just like we know 12 inches equals 1 foot, we have this particular ratio or unit conversion that says 180 degrees equals pi radians. If we were converting from inches to feet, we would use a conversion factor, and those are the same conversion factors that you'll see down below. If we want to convert from radians to degrees, we use the ratio on the left. If we want to convert from degrees to radians, we use the ratio on the right. Let's go through some examples of those. For the first one, we have 30 degrees. We know it's the unit of degrees, and we want to convert to radians. So when we're converting from degrees to radians, we use that ratio on the left. So it's going to be pi radians over 180 degrees. So if I have 30 degrees, I set up the unit conversion, which has to be equal to 1. So I want to convert by writing pi radians on top divided by 180 degrees. We want to keep this exact, so we're going to treat pi like a variable. So really what we have is 30 pi over 180. This is going to be in radians. We reduce that fraction to pi over 6. These can be either positive or negative. We'll look at how if we rotate counterclockwise, that something is positive, and if we rotate clockwise, it becomes a negative angle. So for this one, we are rotating 120 degrees clockwise. Again, we'll use that same conversion factor, multiply by pi radians over 180 degrees. So really, again, what you're doing is you're looking at negative 120 over 180. Your units of degrees cancel out to be your answer in radians. You reduce your fraction and get negative 2 pi over 3. For 75 degrees, again, we're using that same conversion factor, pi radians over 180 degrees. So you have 75 pi over 180 degrees. Reduce that fraction, and we get 5 pi over 12. If we want to go opposite, this time we want to go from radians to 2 degrees. We're using the reciprocal of the conversion factor we just did. So our goal is to cancel out the radian measure. So this time we're going to multiply by 180 degrees over pi radians. It's going to allow us to cancel out those pi symbols. So we're going to take pi over 4 and multiply it by 180 degrees over pi radians. The nice thing about this time is that your pi units cancel out and leave you with just numbers. So really what you have is 180 divided by 4. Once we do 180 divided by 4, we get an answer of 45, and we're talking about degrees this time. For negative 5 pi over 3, again, we're going to multiply by that same conversion factor, 180 over pi radians. Again, your pi symbols are going to cancel out, leaving you just the numbers. So we're doing negative 5 times 180 divided by 3. We can type that in the graphing calculator in our cell phone, get that number at negative 300 degrees. One last example here. Use that same conversion factor, always using that same conversion, multiplying 180 degrees divided by pi radians. For our last example here, the pi's again cancel out, and we can see that we have just the numbers 180 degrees divided by 12, giving us 15 degrees when we reduce that fraction. This is the end of lesson 3. Your homework assignment is on here along with a WAMAth assignment. The exit task will be given in the Zoom meeting.